Math 1332, Chapter 11, Statistics, Section 3, Measures of Average, Video 5, Estimating the Mean for Grouped Data. We're going to close this series with another formula for calculating the mean. And you might be thinking, great, I know how to do that. Mean is just average. I add up all the numbers. I divide by however many numbers I added. Poof, there's the average. Except there's a problem when your data is grouped. And you'll see what it is, and we'll come up with a way of overcoming it. For example, below is a grouped frequency distribution for students' scores on a recent exam. Estimate the mean score. In the score range of 40 through 49, so in other words, the 40s, one student scored in that range. In the class of 50 through 59, the 50s, two students scored in that range. Two students scored in the 60s, three students scored in the 70s, 7 students scored in the 80s, 5 students scored in the 90s. And we want to estimate the mean score, the average score on this exam for this class of students. Do you see what the problem is? How do you start calculating a mean? You start by adding up all the values, in this case, adding up all the test scores. But what were those test scores? For example, the one student who got a score in the 40s, did he get a 40? Did he get a 49? Did he get a 45? Did he get a 43, 48, 47, 46? Any of those grades. The problem with calculating the mean when you have grouped data is that you lose the specific data that was filtered into groups. For example, the last group of 5 students who scored in the 90s, did they all score 99? Did they all score 90? Did 2 score 90, 1 score 92, 1 score 95, and 1 score 98? Problem is we don't know. That's the problem with grouping data, is that you exchange specificity for something that's easier to digest. Oh, 5 people made the 90s. I don't know what they made. So how can we possibly come up with a mean score when we can't even do the first move, which is add up all the scores? And the answer is we can't come up with the exact mean because we don't know the exact scores. But we can come up with an estimate if we can come up with the best guess for each score. For example, the student that got a score in the 40s, what do you think the best guess is for their score? And you might be thinking 45 and you would be close. The best guess would be the average of all the values in that range. 40, 41, 42, 43, 44, 45, 46, 47, 48, 49. So I could add up all those numbers and divide by 10. And that wouldn't be wrong, but there's a quicker way to do that. When you have a bunch of numbers in a row and you want to figure out their average, if those numbers are evenly spaced, you can actually calculate the average of all of them by simply calculating the average of the highest and the lowest, the mid-range, if you will, or the midpoint. So what we're going to do for each class is come up with the best score to represent that class. And that score is going to be the midpoint of the class. If you watch the video on frequency polygon for a group data set, then it's the same midpoint that we did before. In other words, what we're going to do is we're going to use the midpoint for each class as the best guess for each student's grade in that class. For example, in the first class, 40 through 49, the midpoint, which we can now actually call mid-range. Well, we'll call it midpoint because it's a class. Mid-range is for a group of values. Midpoint is for a class. Midpoint of the first class is 40 plus 49 divided by 2, which is not 45, but is actually 44.5. You can do the math and check it if you don't believe me, but it's right. 44.5 is the best guess for that one student's test grade in the range 40 through 49. And the same thing for the next one. For the next class, 50 through 59, the midpoint is going to be the average of 50 and 59, which is 54.5. So for the two students that made in the 50s, the best guess we have is 54.5. And I think you can probably predict how the rest of these are going to go. If you notice, the midpoint went up by 10, which makes sense because each class is going up by 10. You can calculate them all individually, but at this point, it should be pretty transparent that the next midpoint is going to be 64.5. The mean or the average of 60 and 69, and then 74.5, 84.5, 94.5. Let's put all of those in there a lot more cleanly. And there's all of our midpoints. Remember, these numbers represent the best guess we can make for each student's score in those given ranges, since we don't know what their exact scores are because the data was already grouped. All right, so we're pretending that the first student in the first range made a 44.5, the two students in the second range made 54.5, the two students in the 60s both made 64.5, the three students in the 70s all made 74.5, the seven students in the 80s all made 84.5, and the five students in the 90s all made 94.5. Now we have our best guess for each person's test score. So how do we find the average now? Add up all the test scores, add up all the midpoints? Well, not quite. If you were to add up all of these, you're leaving a lot of people out. Because if I were to add up all 6 of those, I've only got one person in the 90s, and I'm supposed to have 5 people in the 90s. The most common mistake people make here is they will add these midpoints. That is not what we need to add. What we need to add is 44.5 once, 54.5 twice, 64.5 twice, 74.5 3 times, 84.5 7 times, and 94.5 5 times. So we could do this. We could go this plus that again, plus that again, plus 3 of these, plus 7 of these, plus 5 of these. But there's got to be a more efficient way than just adding those numbers over and over again, right? Of course there is. For example, take the ones in the 80s. Take these 7 scores. Remember, there were 7 people in that group. And we're assuming each one made it 84.5. So when we're calculating the mean, we would add 84.5 7 times. What's a faster way to add 84.5 7 times besides saying 84.5 plus 84.5 plus 84.5 7 times over? The faster way to add 84.5 7 times is to do 7 times 84.5. That's what 7 times 84.5 literally means. It means 84.5 plus itself 7 times. So instead of doing a whole lot of adding for each class, we're going to do a little bit of multiplying to help us expedite the addition. For each class, we're going to multiply the number of students, the frequency, if you will, times the midpoint. Again, it doesn't really say frequency in the second column, but the number of students in each class is the same as saying the frequency. And this will help us expedite the addition. Now, the first one is easy. 1 times 44.5 is 44.5. But when we add up the people who got in the 50s, there were 2 of them times 54.5, which is going to be 109. And for the 2 people that scored in the 60s, there were 2 of them. We're assuming they both made a 64.5. That's going to be 129. Now be careful looking for a pattern over here because we're multiplying by different numbers each time. But to help add up all the scores, we're going to multiply each score, each midpoint, which is a best guess for the score in that class, times the number of times it occurred. And if we do all of them, it will end up looking like this. In each row, I wrote not only the answer, but the multiplication problem that resulted in it. For example, in the last row, there were 5 students. We're estimating that they each scored 94.5. So the sum of their scores is 5 times 94.5, which is 472.5. All right, so let's keep in mind what we're trying to do. We're trying to find the average score. We had to guess the average based on the midpoint of the classes. And to help add up all the scores, we multiplied each class's midpoint times the number of students in that class. But now we have to finish adding them. So we just have to add up all of the products that we just found. We know the sum of the scores in the 40s, the sum of the scores in the 50s, the sum of the scores in the 60s, or rather I should say estimates, the sum of the scores in the 70s, the sum of the scores in the 80s, and the sum of the scores in the 90s. So to find the sum of all the scores, all we have to do is take the sum of this column. Remember that capital sigma means a sum. 44.5 plus 109 plus 129 plus 223.5 plus 591.5 plus 472.5 is 1,570. So, to our best guess, this is the sum of all the test scores. And I say best guess because we had to guess what each test score was in each class. Remember, we're finding the average. How do you find the average numbers? You add them all up and divide by the total number of scores. We've just added them all up. Now we have to divide by the total number of scores, or in this case, the total number of students. How many students were there? If you said 6, you're wrong. There were 6 classes, 40s, 50s, 60s, 70s, 80s, 90s. How many students were there? The answer is whatever this adds up to. If we take the sum of this column, this one's easy. 1 plus 2 plus 2 is 5. This is 5 plus 5 is 10. There's 10 more, so there are 20 students. Let's get rid of all those marks. So here's what I know. When I add up all the students' test scores, or at least the best guess, I get 1,570. And there were 20 scores. Therefore, here's a blast from the past. The mean, which is still X bar, by the way, is 1,570 divided by 20, which is 78.5. So based on the information I was given at the beginning, and remember that was just this, based on the information I was given at the beginning, the best estimate for the mean score on this test was 78.5. All right, let's review what happened before we summarize it, because this is actually pretty straightforward. Step 1, step 2, step 3, get your answer. You just got to stay focused. So what do we do first? The first thing we did is we calculated the midpoints, because we didn't know what each actual value was for the student. So we had to make our best guess by averaging the high and low end of each test score range. Then to help us add, we multiplied each midpoint times its frequency. Or rather, I should say frequency times midpoint. It's the same either way, but I am going to change it to frequency times midpoint just because I wrote, actually, I'll leave it there. It's multiplication, doesn't matter. Multiply each midpoint times each frequency to help with the adding of all of these test scores. And then we added up all those scores, or all those products. But then we had to divide by the total number of students. And when we did that, we finally got our mean. So to summarize, for those who take good notes, wink, wink, nudge, nudge. To estimate the mean for group data, step number 1, calculate the midpoint of each class by finding the mean of the lower and upper limits. Translation. Average these two numbers to get this. So do a lot of averaging of two numbers. Step 2, multiply each midpoint times the frequency of the class. Meaning, you calculate this column, running out of things to highlight. You calculate this column by multiplying these two columns together. Multiply straight across. Your third step, find the sum of the products found in step 2. In other words, our third step was to add up the last column to get this sum. Your fourth step, oops, wrong page. Your fourth step is to find the sum of the frequencies. In other words, our fourth step was to add up the second column, which we were given, to tell us how many students we had, or really how many numbers we're averaging. And then your last step, divide the sum found in step 3 by the sum found in step 4. So our last step was this division problem to give us that answer. It seems like a lot of hoops to jump through, but every move is motivated if you remember what you're trying to do, average a bunch of numbers, and what you need to overcome. The fact that we don't know what the individual values are in each class, so we just average the endpoints of the class, the limits of the class, to get our best guess, aka the midpoints. To close this video, there's a real easy way to summarize all this, but it is completely symbolic. There should be a bar over that X. That'll do. X bar is the sum of the midpoint time frequencies divided by the sum of the frequencies. This captures everything we just did. What's implied by this is that you have to calculate the midpoints first. So maybe I should say where midpoint equals lower limit plus upper limit divided by 2, the average of the midpoints, the average of the limits of each class. But the estimated mean for group data is the sum of the products of the midpoints times the frequencies divided by the sum of the frequencies. It is very straightforward, but it takes practice. That means you need to do it instead of just watching me to do it. And that's the end of this video, and the end of the videos for this series, and the end of the videos for this chapter.